All right. Happy day to study compound inequalities. So, given these two graphs, combined inequalities shown below. So the first one is showing between -12 and 3 with a closed and open circle, and then greater than 8 all the way up to infinity. This one's from -infinity to -1, and then from 7 to 14. What would be the graph for the first and the second? So the first and the second is where they're both true. And so that would basically need to take all of that to all of that. And so it would look like this, going from -12, closed circle, to 3. And then here, it goes from 8, with an open circle, to 14. So the and would look like that, okay? If I'm okay with either of them being true, an or statement basically takes the union of everything. And so whether just one is true, or like here where both are true, or here where just one is true, we take it all. Same thing here. Here where just one is true, and then here where both are true, and then here where only one is true. And so you would actually get this graph that goes from, here, I'll draw it up here, from 3 all the way down to -infinity, and here a closed circle at 7 all the way up to +infinity. Okay, so your way of thinking about this is and is a conjunction and or is a disjunction. The symbol is intersection is an and union is an or. And here we're looking for the overlap. And so when you have an overlap, when you put red and blue together, it makes purple. So what changes color when you're mixing colors? Okay. But here, anything that's in color is what we keep. Okay. And then finally, we can start looking at some examples. So here, x is greater than 3 and x is less than or equal to 7. So where would this red and green overlap? Right here in the middle is where our solutions are, okay? And then over here for x is less than 5 or x is greater than 9, whether I'm colored in on this purple side or that purple side, I'm happy with the solution, okay? Over here, this is x is greater than -4 and x is greater than or equal to -6. And it's an and. So I need all the places where they're both colored in, which would just get me from here and to the right. On this guy, we need and. Well, where are we simultaneously over here and over here? And the answer is nowhere. So we can say the empty set. All right. Down here, less than 2/3 or less than 4. Well, I'm happy if I'm colored in here, both, or just one. And so I would color in all of this. Okay. This is a tricky example because this needs to be true. This needs to be smaller than that, which also needs to be smaller than that. And so we actually get these three statements where these first two need to be related. 2x plus 3 needs to be less than 5x minus 7. 2x plus 3 needs to also be less than the biggest, 10x minus 20. And 5x minus 7 needs to be less than 10x minus 20. And if you solve all three of these equations, here I'm going to move the 7 here, add 7, and we get 10. I'm going to subtract 2x, and we get this. And we get x needs to be bigger than 3 1/3, so 10/3. Okay. Here, if I'm going to always move it to the bigger x side, the one with more x's, so I don't deal with negative x's, and we get 23. And if we divide this, we find that x is greater than 23/8. Okay. And then here, if we move the x to this side, we get 5x, and we add 20, and we get 13. And we basically get x is greater than all of these numbers. X is greater than 13 over 5, which is about 2.6. X is greater than 23 over 8, which is just shy of 3. And then this is x is greater than 3 1/3. And so all three of these need to be true. We need to be greater than 2.6. We need to be greater than 23/8, and we need to be greater than 10/3. And the only way that all three of those are true is if we are greater than 10/3, because this is an and. This needs to be true, and this needs to be true, and this needs to be true. And the only place where all three of those are colored in is over here, okay? Then we get into some more tricky ones, okay? So this one, similar, you're going to want to split up and set up your three inequalities and solve those and find out where they all are colored in, Okay, this one, we have less than 0 or greater than 6. So that's the red. We have x's between -2 and 8 with open endpoints, and it's an and. And so we're looking for where both of them are colored in, which would land me somewhere in this range. They're both colored in from here to here, and then they're both colored in from here to here. Okay? Down here, you just got a lot of algebra to do. It's an or, so we're looking at the overlap of both. So if I subtract 7x on both sides, I'm going to get a negative, which is fine, but you need to remember your rule of when you divide by a negative, you flip the inequality. That's because we're applying a strictly decreasing function. We'll talk more about that if you have questions. So we're getting x is greater than 3 over here. I don't like fractions too much, but whatever. Let's distribute 3/2 x plus 15 over 2 greater than, I'm going to write everything here as something over 2 because that'll make it easier to combine like terms. 8x over 2 minus 2 over 2. Okay. Oh, my pen is not happy with me right now. Minus 2 over 2. And if I subtract 3 over 2x, we're going to have a 5x over 2 over here. And if we add that, less than 17 over 2. And if I multiply by 2/5 on both sides, the 2's will cancel. We get 17 over 5, which is 3.4. So we get x is less than 3.4 or 3.4. And so we're greater than 3. We're less than 3.4, and it's going to look like this. Whew. All right. On these, when you're solving these, any work that you do in the middle, you can just do on the left and the right simultaneously. The reason why I had to split up the other ones is because they all had y's, and so you can't isolate 3 separate y's at the same time. But here, we're in good shape. Less than or equal to -4y, less than or equal to 17. And we divide everything by -4. You need to remember that this is going to flip all of those inequalities. So I'm going to put this 5/4 on the bigger side, -5/4, excuse me, is now on the bigger side instead of on the smaller side, and then y, and then on the smallest side we get -17/4. So this is about -4.25, and this is -5/4, -1.25, and so we get some closed circles there. Oh, here I'm going to draw this above the line so we can find where they overlap. So this one, if you subtract 19, we get -16 less than or equal to -8y, less than or equal to 8. And then when we divide everything by -8, we get, flipping over here, we get a +2 less than or equal to y, less than or equal to a -1. And so here's -1, that's -5/4, so that's -1.25 to 2. -5/4, and this was -17/4. And if we're looking for the overlap of this and this, we get nothing. All right, so you got this. Have fun, and we'll see you soon.